All right, friends and neighbors, welcome back. Hey, on this channel we talk a lot about protocols, tables, devices, cabling, how things work, but sometimes we forget to address how we put all those things together in an actual network. And that goes for wired or wireless. So today we're going to talk about some of the things we do to put together a wireless network and maybe some of the reasons why we make the decisions that we do. So let's get to some of those ideas. So this one we're going to call 802.11 number 7, planning your network. Now this is the thing that nobody does, but everybody should do. It's called a site survey. And a site survey is really just you taking a look around to see what might be in your neighborhood. And it's really important on the wireless side, the spectrum side, but there are other reasons that we might do it depending on, what you're trying to cover. But first of all, what you want to do is get a cheap or free spectrum analyzer. Now, lots of phones have an app, but the key is that you want to look at 2.4 and 5 gigahertz portion of the spectrum. And what are you trying to figure out? Well, you're trying to figure out, A, how many other networks might be out there because they're going to conflict with you or have the potential to conflict with you. And maybe, more importantly, is the set of channels that they're using because everybody uses the same channels. And here's the top secret. Nobody changes the defaults. So everybody's going to be on channel 1 or channel 6. So if you navigate away from them, you're naturally going to get better performance. Because just like we can say, well, when we have extra nodes on the network, we have extra competition. If you've got a neighbor out there on the same channel that you are, they're creating interference for you. So you want to try to avoid that if you can. So everybody uses 1, 6, and 11 on 2.4, and everybody uses the low number channels for 5 gigahertz. So take a look around, look at the spectrum. Now you can also take a look around, particularly if you live in an area where there's lots of other folks. So is there a hotel next to you? And the reason that becomes important is because if there's a hotel next to you and everybody's looking to ride out on somebody else's wireless, it might be yours that they're targeting. Plus, they can see your signals. So take a look around and try to understand what your environment looks like. Now the other thing that you can do is that if you're doing a site survey, you're wandering around outside your house or your apartment and you're trying to see what other networks are out there, even if they're on the same channel but they have a really small signal strength, that might not be a problem. But you can do some tests, right? There's nothing wrong with setting up for a particular channel and then navigating to another one if that's a particular problem. Now this becomes a really, really big deal if you live in an apartment because everybody's setting up their wireless networks and everybody can see everybody else. How do we set up a wireless network? Well, lots of folks just have a single access point, right? So you might have a wireless home gateway or something like that. And that's where it becomes really important to figure out what channel you're going to use because that's the only one you've got, right? You're going to set up your access point, and you want to make sure that it doesn't conflict with everybody else. So you do a site survey and you find out that your neighbor here has got channel 11. So you want to use something else. Well, if you're going to set up more than one, what you want to make sure of is that you're using different channels. So a wireless network has a couple of really basic rules. First of all, everybody's going to use the same SSID. Now that sort of makes sense and is probably like duh, of course, but not everybody sets it up that way. So then you figure out where you're going to lay out your access points, and what you're trying to do is avoid the channel overlap problem where the same two channels overlap each other. Channel overlap with different channels is actually a good thing because that ensures coverage for your SSID. In addition, everybody's got to have the same security. So if you set up WEP or WPA-PSK on one particular access point, it's got to be the same for everybody because otherwise the minute you try to roam to that SSID on another access point, you'll have the wrong security tokens. So the two names that we have for a wireless network are a basic service set and an extended service set. A basic service set is just the access point and the nodes. An extended service set includes what we call the distribution system or the wired side. Wherever you can, make sure you got the highest possible connection or highest possible speed connection that you can manage to that switch. Today we get gig interfaces everywhere. So that's just what we're after. And this becomes especially important because as you get better and better wireless networks, they have more and more throughput, and you don't want to send it to a port that's a lower speed. So best possible port, best possible cabling, best possible jacks that you can manage. Location, location, location. 2.4 and 5 gigahertz spectrum or channels have different ranges. So the basic rule of thumb goes like this. The higher in frequency you go, the shorter your range. So an 802.11 2.4 gigahertz cell looks like this, and then when you have 5 gigahertz it goes down to here. So that's just a basic fundamental property of wireless transmissions. So what we want to do is figure out where you are going to work, where you're going to be, and then place the access point as close as possible. Now, if you're within a house, then it's not a big deal, but still, the closer you can be, the better off it's going to work. Not everything has to go inside the basement. Antennas have something called an alignment or an orientation, and so if you're immediately above or immediately below, you can actually change the signal strength that you're receiving, especially if you don't have external antennas on your access points, or the DVD player that you're hooking up, or the console, whatever it is. We want to be mindful of our environment. Now, this is part of your site survey, but when you are taking a look around, if you want to put your access point, behind the water heater or next to the furnace, well, that's metal, and so that creates a problem. And in the case of the water heater, you've also got water too. So these are enemies to electromagnetic propagation, and so we want to avoid those if we can. Now, don't be afraid to wander around your property or your apartment to figure out what your signal strength is going to be and see how far the range is. So what that does is you say, well, I might work over there, I'll work over here, I'll work up there, and you'll know then what the signal strength is going to be. Whether it's bars or actual decibel levels, you'll understand what your signal strength is going to be, and then maybe decide to move your access point. So let's talk a little bit more about channels 1, 6, and 11. Why do people pick channels 1, 6, and 11? Well, in 2.4 gigahertz, what we're really talking about is a range of frequencies from 2.4 to 2.5 gigahertz. That's 100 megahertz worth of bandwidth. And the reason that we use channels 1, 6, and 11 is because those channels have actually expanded to be the wider, high-speed channels. But how do you expand a channel? Well, it turns out that in 802.11, we expand up. So it's actually channels 1 through 5, 6 through 10, and then 11 and on up. And in this country, we don't use channels in the higher portion of the range. So that's why everybody uses channels 1, 6, and 11. You can use 3 if you want, or 8, but you're going to overlap when you try to go high speed. So that's why everybody uses 1, 6, and 11, to get wider, non-overlapping channels. In addition, we can't add more channels because we've got guard bands in between the individual channels, that is, frequencies that you don't use to prevent overlap. Now at 5 gigahertz, all the channels start off at 20 megahertz. So they're all wide, and there are more of them. There are 12 of them in the 5 gigahertz range. So we don't have the same overlap problem. The spectrum is wider at 5 gigahertz, so there's more frequencies available to us. And by the way, if you're setting this up, you might see channels like 36, 40, 44. Those are the 5 gigahertz channels. Now I'm going to do a whole other video on security, but let's get down to basics here. If we're talking about your home network, don't allow outside login. And by the way, make sure you do HTTPS or SSH to get in. Change the default. And that can include the IP address, but definitely the password and the SSID, right? There are web pages that publish all of these default values, so don't stick with the defaults. Make sure you change them. Now, WEP has a really bad name, but it's better than nothing. So if you have older gear or WEP is what you know, set it up. Somebody's actually got to attack you, right, to get in. Certainly WPA-PSK version 1 and version 2 are improvements over WEP. So make sure you turn those on. It's an astonishing number of networks still don't have wireless security. And by security, we mean encryption. It's amazing how many people don't have encryption turned on still. Now, wandering around for your signal strength reading also gives you an idea of what your exposure is. This is particularly true if you're in an urban setting or you're in an apartment building and you're wandering around seeing who can see your signal, right? The more you blast out that signal, the more other folks can see your signal, which means they might have the ability to use your wireless network, they might have the ability to conflict with or create interference or attack your network. So taking a look around gives you a better idea of what your exposure is. Well, this has been sort of a back to basics video, but it does get to a lot of the reasons why we set up wireless networks the way that we do. Take a site survey, figure out who's around you, but also figure out what your exposure is. Make your channel decisions and your spectrum decisions based on that. Walk around, figure out where you're going to work, and then put your access points in the best possible location. Make sure you turn on security. Hopefully this helps you set up your own network, or if you've got a network set up already, sort of tweak your settings and make sure that you're working in the optimum fashion. Thanks for watching, thanks for listening. Like and subscribe if I helped. May those wireless packets always reach their destinations, especially now that we've done the job right.